So here we got.
Did you check the audio?
It's going, don't worry. Look, you can see them. Look, see the microphone going? Here we go. Here's how I want to introduce this topic. Let's write out sine law for this triangle here. Okay? So let's just, this is a good little segue here. Okay? So sine A over A is equal to sine B over B is equal to sine C over C. Okay? And that, now let's fill in the information that we know. Okay? So we can go sine A, because I don't know angle A, but I know side length A is 8, is equal to sine of 25 over x, which is equal to sine of C, which I don't know, over 14. What's the problem with this? X is just the side length, so you can call it B if you want. Sorry. Yeah, okay, that's fine. Maybe not the best thing to do. I just copy pasted the triangle from somewhere. Okay. I'm stuck. It doesn't matter which two ratios I pick. I only know 2 of 4 pieces of information. Right? That's the point. You could pick any of the 2 that you want. You're still only going to know 2 of 4. Which is where sine law breaks down. You can't use sine law here because it's useless. You're always going to have 2 knowns and 2 unknowns. Okay? So, this is probably my favorite part of all trigonometry, what I'm about to show you. So, what color is coleslaw? Have you ever had coleslaw? Coleslaw. It's green and white, right? It's got some green and white in it, right? There's some coleslaw right there. And then we've got 2 buns. This is what we call a coleslaw sandwich. Yeah. It's a coleslaw sandwich. 2 side lengths and an angle. Anyway. No, I'm not a coleslaw. I mean, I like math coleslaw. But I don't like the food. Okay? I say that because this is a recognition technique, right? As soon as you see kind of this coleslaw sandwich, you know you have to use cosine law. Okay? So if you see a side angle side, you can't use sine law. Okay? You got to use cosine. So, we'll come back to that. We'll actually solve a problem using cosine, obviously. But here's the cosine law.
Wait, what did you say the top? SAS?
SAS, so side angle side. SAS. Yeah. That's what they say. Okay? This should be your favorite now. Okay? So here, I'm going to rewrite. Obviously, you could solve for any one of the 3 side lengths in a triangle using this, because I've told you it has to work, right? So there's 2. Here's cosine law if you were to solve for side length A. But what does it look like if you were to solve for side length B or C? Right? It's going to take on a few different forms. So here's the way I remember this, and hopefully you guys just follow this, okay?
Well, I'm getting it.
The theta you could turn into an A, cosine A of the angle, right? And so if you look, the A's kind of contain the middle section, right? So when I write this one here, the next one, you'll see here, by the time we get to C, it should be locked in. I'll do B squared, okay? So to find side length B, You're going to contain it with the values of b. This is a memorization tactic for you, so you're not having to rely on stuff, right? And then you fill in the middle with the other two. Okay? Yes, Coco.
I don't really get what you just did.
It's like I'm not even doing any math. I'm just giving you a memorization tactic. Like there's nothing to understand. It's just I'm just giving you a memorization tactic. Is all.
Did you switch the B and A?
Yeah.
And then the cos stays everything plus B?
Yeah. Cos A. I kind of changed it in the top two. It's just an angle, right? It's cosine of the angle A. Okay.
I can't read what you, is that like 28?
2AC.
Oh,
Here, I'll space it out. I tried to. Is that better?
yeah.
Okay. Okay, the main idea here, and this is purely, there's no math going on here at the moment. It's just a purely memorization tactic. Okay? Then you just fill in the opposites on the inside. Okay, so if we were to do the last one, c squared should equal the other two. A squared plus b squared minus 2ab cosine c. All three of these now, it doesn't matter what side length I ask you to solve for, you get to pick one and just plug in the information you know into the cosine law. It will spit out an answer for you. Can I, did I do it anywhere else? I haven't looked at this in a while. One sec, just give me a sec. There's something else cool about this. Okay, I don't think I did it anywhere else. So let's just one other additional thing. What is Pythagorean theorem? Do you remember? This is a little bit of a drawback. A squared plus b squared equals c squared. Do you see that anywhere else on the page? C squared. C squared. A squared plus b squared. A squared plus b squared. Okay? Plus a little bit extra. It's just Pythagorean theorem with a little bit extra on the end. Okay? That's, I guess, my point there. I'm just trying to give you a memorization tactic, right? So if you're given, like, you can write cosine law once on your test and then rearrange it or shuffle it up in order to solve for whatever it is that you're asked to find. Okay? Now, that's purely to solve for what? We're going to do questions. Don't stress. Okay? And it'll be the same thing as sine law. The more times you do this, it just locks in. But this is for, strictly speaking, what? Does this allow me to calculate angles? Just the side lengths. If solving for side lengths, that's the form that it takes on. Okay? So, here's the next little cool piece. I want you to take a second. Tell me what the cosine of 90 is. You guys go to your trig table or type it in your calculator. Okay, go find 90 degrees and tell me what the cosine of it is.
0.
Interesting. So if I wrote out cosine law, right? You guys told me that the cosine of 90 was equal to 0. So what's this turn into? What happens? If I multiply that second piece by 0, the whole thing disappears, right? What's left? Pythagorean theorem, or some derivative of it. It's like magic. This piece on the end is cleaning up some stuff. Not necessarily visual to you right now, but it's just an extra piece on top of Pythagorean theorem to clean up some of the odd angles, okay? Is that okay? This is all tidbits of information. Like, I'm not gonna ask you a question to like do like what I just asked, what happens if the theta is 90. Like, I'm just giving you some context here as to what's happening, okay? Okay, I will ask you to solve for things. Okay, which is what we're gonna do next. Any questions? Okay, this just is what it is. These three things up here are very important. Okay, I would know these, or at the very least know one of them and know how to rearrange to get the other two, or just rewrite the other two, okay? So, next thing, let's actually solve a question. So again, what do I see here? Somebody please say it, because it's funnier when I don't say it.
What is it?
Well, what do you see? It's a coleslaw sandwich. Right? A side angle side. It's a sassy question. Okay?
What makes it called coleslaw? Like, why is it?
You ever it's coleslaw? You ever had coleslaw? You got like fish and chips or anything like coleslaw, like cabbage?
But why is this specifically coleslaw?
Yeah.
Because it's cosine law.
Coleslaw? Coleslaw?
It's cosine law, so it's coleslaw sandwich. Okay. That's fine. If you don't like my jokes, don't like my jokes. I'm going to keep saying them, but it is what it is. Okay?
Hi, Mr. McKay.
Yeah?
Do you mind picking up the...
Yeah. Okay, I want you guys to try and solve for x. Label the triangle ABC and try and solve for x. Okay. So you can not label it X, that's fine, whatever. If you guys want to label the triangle as A, B, and C, X must be little a. This is the same thing as sine law, okay? Nothing's changed from sine law yet. You're just going to use a different equation. You're still labeling the triangle as is. Little c and little b. Okay? So if I want to find A, right, because that's what it's asking me for, it's A, it was X, then I write out cosine law with A squared. A squared is equal to B squared plus C squared minus 2BC cosine A. What you will find after you write that out is you know every piece of information in here. So you just plug it in and type it into your calculator, and that's it. Okay, so let's go through there. The hard part is selecting what equation, I guess, you need, or at least identifying when cosine law needs to be used. A squared is the thing you're trying to find. It's going to stay A squared. B squared is 17. C squared is minus 2 times 17 times 11 cosine of angle A, 53. Everything's there. You just type in your calculator now. I don't know what 17 squared is, though. You guys will have to help me with that one. 289 plus 121 minus, what do I get here? 34 times 11, 340, and another 374.
What is it?
This right here, is this 374? You guys tell me, I don't know. I'm good, eh? I'm good. On fire today. Okay. The other thing you can do is you can go find right off the top, you can find what the cosine of 53 is and plug it in. So you go to your trig, you can go to your trig table. You go find 53 and you read off what the decimal value is for 53 underneath the cosine column. So 53, you should see 0.60 0.18.
Yep.
Good. Okay. So now you just do the math. Keep collecting it. Putting all the pieces together. A squared is equal to, what's 289 plus 121? 410 minus, I need somebody to do that though for me. 374 times 0.6018. A equals square root of 184.9.
What happens if you like, I mean this is a couple steps up, but like, what if you know when you have single brackets, what if you did the math first and then multiply that number? Would it, like,
Right here?
no, one more down?
This?
Yeah, what if you did with the math and then multiply it?
You can't. Don't do that. Some of you are doing like little weird things, like on the last test. There was some funny, weird things going on that like shouldn't happen, but it's kind of like it is what it is because we've missed, like some of you did not take grade 9 math basically is what's happening, right? That's a fair assessment. Yeah, right. Just, the question is, can I do this plus this minus this and then multiply by the number?
Like I know you get a different answer, but like what makes you know?
You have to abide by BEDMAS. That's like the fundamental. You have to do the division and multiplication before you do the addition subtraction. That's just a rule, okay? So don't a few of you were doing that. I'd never seen that before. It's not even something I would think of correcting, right? It was where we're just like this plus this minus this, and then take the number and multiply. Like it's weird. It's just like some odd thing that I never even would have thought of. But that's a product of not having really a great grade 9 math experience, you know?
Isn't BEDMAS like way before?
Yeah, but the actual application of BEDMAS is something that, like in different contexts, is something that you lose thought of, you know? Like sometimes I just take for granted, like in the back of my head, I do things in a particular order that satisfies BEDMAS, and that's just because I've been doing math for so long, you know? Like I don't even think that that's a thing. It's one of my like subconscious biases, you know? But that's, just follow this, always. You will get in the habit of like doing bracket work, then exponent, then the division and the multiplication, and then addition, subtraction is like the easiest thing. That's what you're gonna do at the very end, right? You wanna do the hard stuff first, I guess, is in my head what's going on subconsciously, right? Just be careful. That's all. You guys know that. It's just, it's easy to just, there's lots of little things that I do that I forget sometimes, you know? That's all. Okay? So everybody should get that. Okay, so it's kind of cool that like you have 3, 4, 5, 6 things there, and you know all of them except for one. It's kind of weird that it works, you know? Any questions? Yeah, Retta?
About the test. Oh, like, is the multiplication just that only for angles, though?
Yeah, there would be questions like, oh, what's the vertex of this parabola? A, B, C, D. Look, little simple things.
I feel, say that would we have to factor it, or would it just be as simple as?
No, it's
you
just
already
that
used
it's written in
before?
vertex form. You just read off the vertex. Tell me what the vertex of the parabola is. There's free marks. There's 8 free marks there. For the most part, there might be a couple little tricks in there, but for the most part, it's all an answer is there. You know that much, right? I didn't put any that there's no answer. There's an answer there. You know that.
I hate when teachers put like none of the above or all of the above, and it's neither of them.
I'm not gonna say I didn't do that because I didn't look close enough, but I don't think I did that on this one. I did it on the first one, the first couple I did that, but I don't know if I did that on this one.
Does the exam have multiple choice?
I don't think so.
I don't like them.
I don't think so. Okay, why don't we do, well, we still got 15 minutes, so we might be able to power through a couple more of these. Okay, what is one of the other things that we can solve for in a triangle? Aside from the side lengths? Angles. So I better be able to solve for angles using this thing, otherwise I'm in trouble. So how am I going to do that?
Well, now you don't need to use cosine.
Yes, now Retta's right. If I wrote this on here, just that's a good point Retta made. So everybody look here for a sec, okay? If we say that this is now 13.6, you don't need to use cosine law again. You can go back into sine law from the top and you can fill in that one piece of missing information and use sine law the rest of the way. That's a good point. You're not going to use sine law 10 times in a question because you just don't want to. As soon as you find one of the pieces of information, you can now make that substitution back into sine law, which is much easier. Okay?
You could still use cosine.
You can still use cosine law, but you can see, like, that's a lot of lines. Sine law might be half that. Okay? Cosine law gets you out of a jam. It gives you a piece of information that you can now use sine law for. Okay? You don't want to do it 10 times. Yeah.
If you were to do like cosine to find the angle, would you just write all of your sides and then at the end keep like cosine of like b blank? You don't know b, you're looking for it, right?
Are you asking like how to rewrite the equation?
No, wouldn't you just like use all of your three side measurements? You have you have what you need to know, right?
To do what, sorry?
To find the angle if you're to use cosine law.
Oh yeah. You could you just plug in the information, A, B, C, and then, but the problem is I haven't shown you how to solve for the angle using cosine law yet. That's what I'm about to show you. Okay? So, what I'm gonna do down here, I'm gonna rewrite one of the cosine laws. Okay, just maybe the first one. A squared, you guys copy this down, equals b squared plus c squared minus 2bc cosine A. Okay? So I just rewrote, I haven't done anything new, I just rewrote one of the cosine laws. Okay? This here says, I'll change this to an A, rearrange this cosine law that I just wrote down to isolate for cosine theta, or cosine A. That's going to allow you to solve for the angle. So basically what I'm asking you to do, and you're only going to do this a handful of times, is to rearrange to get cosine A by itself on the one side of the equal sign. And that's it. So let's just do that. So I'm just going to start moving the easy stuff over to the other side. So I'm going to get a squared minus b squared minus c squared is equal to negative 2bc cosine A. Is everybody okay with what I did there? I just subtracted a b squared and a c squared from both sides of the equation. I'm just solving. You guys know how to do this. There's no fancy way of doing it. It's just solving. I'm isolating for one piece of information that I'm interested in. In this case, it's cosine A. Okay? How do I get cosine A by itself now? I can divide both sides by negative 2bc. They now cancel. You're left with the cosine of A is equal to A squared minus B squared minus C squared over negative 2BC. Is that okay? You guys know how to isolate for variables. That's all it is. It's isolating for cosine A. Now, if I wanted to write, what if I wanted to solve for cosine of C or cosine of B? How are you going to write those? You just look at, you can look at your parent one, or like the one we just finished doing. Take a close look at it, and you just start rearranging things. So if I'm going to write one that represents cosine of B, okay, I'm basically going to steal the B out of everywhere I see a B and replace it with the A, and vice versa, right? So cosine B is going to be equal to B squared minus A squared minus C squared over negative 2AC. Again, this is like this is just a memorization tactic for you, right? I'm just trying to give you this. That's not necessarily math. I'm just talking. I'm talking to you to show you what I've talked about, like what we're doing there physically. We're just putting different variables in different spots. It's just to rewrite it so that you don't have any thinking to do, Coco.
Are you allowed to change the last one into negative 2AC? Like, hello? Shouldn't it always be negative 2AC?
Not if, what if I rewrote basically where this came from, right? If I rewrote this, this is B squared is equal to A squared plus C squared minus 2AC cosine B. That's where that came from. And I would have done the same work that I did in the top. I just isolated for cosine B. I would arrive here.
Okay, so then like, say it was C squared, okay, would you turn it to negative 2AB or something?
Yeah, do you want to do C? I'm going to do C right now. We're going to try and solve for angle C now. Again, you're going to be like, I'm going to give you one of these things on a test for side length and angle, and you will have to like come up with the other two if you need it, right? So we'll do the one for C in purple, okay? So we'll go cosine of C is equal to, you're going to lead off with the C squared, then you're going to go minus the other two. B squared, there you could go A squared, all divided by negative 2BAB. That's where those come from, okay? And all I'm doing is the same work that I did up here with just one of the side length equations, each of the three side length equations. I'm just rearranging the side length equations, okay? Okay, chances are we have enough time to do example 2, as long as everybody's okay with that, okay? So just copy those down, make sure you got all three of those, because those are important. You may need any one of those three under any of a particular question that I give you, okay? And again, as Retta said, once you do this once, you've unlocked another piece of sine law, so use sine law the second time, okay? If it says solve the whole triangle. Don't do this 3 times. Okay. Are we okay? Okay, so we've got a side angle side, so I know I'm using cosine law. But I want to solve for, this is alpha down here in the bottom corner. Okay, that's your Greek letter. That's what we're trying to solve for. So let's label the triangle. Okay. It can be A, B, and C. Okay, and I'm gonna solve for angle B, right? That's what I'm after. So I'm gonna rewrite cosine law. Cosine B is equal to b squared minus a squared minus c squared divided by negative 2bc. AC, sorry. Okay, and then you go back to your triangle. You can label this C. This is going to be little a, and this is going to be little b.
Scared me?
So you just plug the stuff in. Right, so cosine of b is equal to b squared is 4, or 4 squared, minus a should be we have a problem. There are two pieces of information that I'm like, I don't know. Right? What I'm doing is I'm trying to run you guys through like I just jumped into this question and like I assumed that it was just going to be cosine law, right? You're going to do the same thing, I guarantee it. Where you're like, oh, I'm just going to try and solve the angle directly. But then you're going to realize, oh, I'm missing two pieces of information. This is exactly what's going to happen to you the first couple of times you try these questions. You're going to try and jump in and solve for the thing directly. Then you're all going to be like, I don't know what to do. I'm missing two things. That's fine. You're just going to backtrack a little bit. So in your head, you're like, okay, well, if I find this, I can then use sine law to find the angle. So you can't always just necessarily jump right in and solve for the whatever it is you're looking for, right? You might have to like, this is a perfect instance, right? I jumped right in. You're going to do the same thing. Where you're like, I'm just going to try and solve for it. So that's fine. Like we're stuck. We can't actually do that portion, but what we can find is c squared. We can find c squared first, that I can use sine law after. Okay? It's okay to hit barriers. It's just how you like think your way out of the hole, right? I just did that in 5 seconds because I was like, oh, I had 5 seconds of like, I don't know what to do. I'm the same way as you. Your 5 seconds might be 30 or 40 or 50 or 2 minutes, right? I don't know. The point is we're all going to hit these barriers. So you just got to think your way out of them, right? So that's fine. So I'm just going to find C using what?
You're leaving without the crew.
Cosine law, right? Because I got this cos law sandwich. So just do the same thing we did up top. So we can find c squared is equal to a squared plus b squared minus 2bc cosine c. So c squared is equal to 4 squared plus 9 squared minus 2 times 4 times 9 cosine 110. Okay, so c squared is equal to 16 plus 81 minus 18 and 4 should be 72 cosine 110. I need a number for cosine of 110. I'll show you guys, I promise this afternoon, I'll show you how to use your calculator. Okay, all you have to do is actually go to your calculator, type in 110, hit cosine, okay? We'll get this number and then you guys go for lunch, okay? And we'll finish it off later, okay? What is it, sorry? It's negative? That's okay. It's okay for it to be a negative number. You just take whatever the number is off your calculator and you just throw it in there. So what is it, sorry?
Negative 0.342.
Okay, so somebody's got to do the math on this now. Okay, quickly. I'm going to get two negatives make a positive, right? So what's 72 times that number? 24.625? Okay, what's the square rootable number? C squared is equal to what? 97 plus that number.
121.6.
Okay, that's pretty close to 11. Square root both sides. C should equal 11 point something.
11.028.
Okay, we'll come back now. You know that answer. We can come back and use sine law later, okay?